Here we go. DC circuit, parallel circuit rules. Number 1 says the equivalent resistance is calculated 1 over R1 plus 1 over R2 plus 1 over R3, etc. equals 1 over R total. Make sure that you know that it's not with what that equals to. It is not this fraction 1 over R total, it's just what's the denominator. So you have to actually isolate everything as 1 over R total, and what's in the denominator is correct. Okay? So the next one is each leg gets its own voltage, gets the full voltage if they're proportional. Okay? Number 3, current is additive. Each leg gets its own current. Kirchhoff's loop rule is I1 plus I2 equals I total. Okay? So you're going to use those rules to calculate on your chart. Now, the first thing and the most obvious thing that I didn't have any room to really, but go down there real close on the bottom, where I did the 1 over R total equals 1 over 3 plus 1 over 3, okay, which equals 2 over 3, but I have to have that 1 over, so it's going to equal 1 over 1.5. So, to fill in my chart, my total resistance is 1.5. Okay? Now, the resistor 1 would be here, and resistor 2 would be here, because whichever is closest to the battery would be deemed resistor 1. Okay? So this is 3 ohms and 3 ohms. Now, as we look at the voltage, each leg, there's a single resistor on each leg, so each leg gets the full voltage, the full potential difference. So it drops from, across that leg, it goes from 6 to 0. So we've got 6 volts in this leg, we've got 6 volts in this leg. Got it? Now, to calculate the current, I have to calculate it individually for each leg. And then, as this bottom part says, Kirchhoff's loop rule says that I1 plus I2 equals I total. Okay? So we're going to have to go I equals V over R. I equals V over R, so it's 6 over 3 is 2. Okay? 6 over 3 is 2. And the total is going to be 2 plus 2, which is 4 amps. So it's a lot more current than was in the other one. Okay? Now, to get to our power, it's the same thing as a while ago. In each individual power component, each individual resistor, the V times the I gives me the power for that resistor. So 6 times 2 is 12 watts. 6 times 2 is 12 watts. There's nothing magical in here, so we know that we have 24 watts of power. Okay? 24 watts of power. Where a while ago you were supposed to calculate for me, or on the other video, you're supposed to calculate for me what those the power in that circuit, series circuit, was supposed to be, and it should have ended up at 6. Okay? So this, since it's in parallel, it uses 4 times the power. It has 4 times the current, that's why. Okay? If there's any questions, ask me whenever I see you on Wednesday, 9 o'clock, 9 a.m. See you then.